Be stubborn. That might be the biggest lesson through all of this. Even the technology from NASA, I was told it wouldn't work. Tried to file the patent and it was put in a desk for 6 months. Pestering, and finally got the opportunity to file the patent. Ended up getting some funding and went and built it. None of the opportunities come easily. And you're going to hear no 100 times, maybe 1,000 times to the one yes. So keep at it, ride the roller coaster of emotions that come with owning a business, and just stick with it.
Welcome to the Lay of the Land podcast, where we are exploring what people are building in Cleveland and throughout Northeast Ohio. I am your host, Jeffrey Stern, and today I had the real pleasure of speaking with Geoff Bruder, co-founder of GhostWorks Engineering and Sonic Fire Tech, a company redefining fire suppression, fighting fires with acoustic wave technology. Geoff's journey is rooted in his work at NASA Glenn Research Center here in Cleveland, Ohio, where he had focused as a research engineer on projects like the Advanced Stirling Radioisotope Generator, thermoacoustic Stirling heat engine designs, and led the design for the Glenn Extreme Environment Rig, the largest chamber on Earth able to recreate surface conditions on planet Venus, so they could, amidst many other things, extend the useful life of power and cooling systems there from 10 hours to nearly 243 days. Since 2019, Geoff has been building Sonic Fire Tech, applying this expertise to develop fire suppression systems that use acoustics, silent infrasound waves, instead of water or chemicals, to extinguish wood and chemical fires from a significant distance away from the fire itself. This approach offers a safer, more sustainable solution for wildfire prevention, home protection, industrial, and other applications where traditional fire suppression methods fall short. I'd encourage anyone curious what this actually looks like in practice to reference the link to a YouTube video in our show notes that demonstrates how Geoff is putting out fire with sound. The video is worth thousands of words. With over 15 patents, 3 publications, a Bachelor of Science in Aerospace Engineering from Embry-Riddle Aeronautical University, graduate work at Case Western Reserve University, Geoff's journey from innovating at NASA to his own entrepreneurial ventures is one of ingenuity and of impact, and I am thrilled to share our fascinating conversation about his vision to transform firefighting. So please enjoy this conversation with Geoff. Lay of the Land is brought to you by Impact Architects and by 90. As we share the stories of entrepreneurs building incredible organizations in Cleveland and throughout Northeast Ohio, Impact Architects has helped hundreds of those leaders, many of whom we have heard from as guests on this very podcast, realize their own visions and build these great organizations. I believe in Impact Architects and the people behind it so much that I have actually joined them personally in their mission to help leaders gain focus, align together, and thrive by doing what they love. If you too are trying to build great, Impact Architects is offering to sit down with you for a free consultation or provide a free trial through 90, the software platform that helps teams build great companies. If you are interested in learning more about partnering with Impact Architects or by leveraging 90 to power your own business, please go to ia.layoftheland.fm. The link will also be in our show notes. So sometimes you hear about a concept so unusual that it just kind of sticks in your mind because of how different and interesting it is relative to what you typically think about. And you gave me one of those ideas when we first met that I haven't been able to stop thinking about since, and I wanted to start with it. So I'll lay it out here and feel free to run with it there. But I had never really seriously considered that the technology that most of us take for granted, working and functioning here on Earth, would just simply not work in Venus. And in what has to be one of the coolest jobs at NASA, you were trying to figure out what it would literally take to have earthly technology, power, propulsion systems, everything else you were contemplating function on Venus. So I kind of wanted to start there. What's going on Venus? How did you come to find yourself working in such an interesting problem space?
Yeah, Venus is an interesting place. Basically, Earth's evil twin. So it's roughly the same size as Earth. So your gravity is similar, but it had runaway greenhouse effects. So 97% of the atmosphere is carbon dioxide, which has insulated the planet very well. So now it's about 1,000 degrees Fahrenheit down near the surface and about 1,500 PSI, 93 atmospheres. So that pressure is like being 3/4 of a mile down in the ocean. And in the atmosphere, there's several different acids. So it rains hydrofluoric, hydrochloric, and sulfuric acid on the surface of Venus. So not a very easy place for hardware to survive.
That doesn't sound like it.
Yeah. Well, and there has not been much of a track record of anything surviving. So the last time anything touched the surface was, I believe, 1983. That was the Venera craft. It was back when Soviet Union and NASA were going back and forth on missions. We were launching the Pioneer missions. They were launching Venera, trying to go investigate Venus. Venera basically was a big titanium ball that hit the surface, survived for 97 minutes, and then burn out. But it was able to send back some images and some data about the atmosphere and things. But that's the last time anything's been there because nothing will work.
Fascinating. Well, how did you find your path to Venus?
I was working as an aerospace engineer at NASA Glenn here in Cleveland and working on power systems for planetary missions. There is a large legacy program called the ASRG, which is the Advanced Stirling Radioisotope Generator. So that's using a small amount of plutonium as a heat source and then using a Stirling engine, very tiny engine, to basically produce 100 watts of electrical power. It's a multi-mission thing, so they plan to use them all over the place, but that wouldn't work for Venus. So there was a couple of us that were looking at how do we take this as a basis and what would we need to do to survive on the surface of Venus. So one of the big things is Stirling engines have moving parts inside, not a lot, but a couple, and those won't survive the 93 Gs of deceleration that you get when you try to land on Venus. So we needed to simplify the device even more. So we used an offshoot of a Stirling engine called thermoacoustics. That's using that heat energy, and then rather than using it to basically move a displacer or a piston, you're creating acoustic waves and then harnessing the energy of those acoustic waves to generate power and using that power to also generate cooling so that you can keep everything in a reasonable temperature.
In your exploration and work with thermoacoustics, did you imagine then that you'd later in life be working in the application of this kind of technology beyond the scope and context of how you were using it then? Was your mind exploring these other applications of the technology at that point in time?
And not outside of engines, no. So it was an interesting thing to be doing, and my push has always been to make a new technology. Frankly, working on the legacy program there at NASA, been around for 15 years already. We're testing engines that somebody else designed, and I was wanting to do something new. I jumped at the chance to go work on the NASA tech or on the Venus tech. So outside of power systems, no, I wasn't thinking of any other uses for it, nor acoustics in general.
So when you reflect on that arc of your professional journey and time through NASA and before, and did you have this entrepreneurial inclination within that you were aware of, or how did you come to recognize the opportunity to and desire to try and build something, and what do you feel motivated you to take that leap ultimately?
I knew that I wanted to go sort of to do my own thing eventually. So I went to Embry-Riddle Aeronautical University. It's all aerospace engineers and pilots. Lots of folks go from there to Boeing and now SpaceX and that sort of thing. I did 2 internships with NASA. When I was leaving Embry-Riddle, I had 2 job offers with NASA, one here in Cleveland to work on power systems, another one over in Dryden to work on aircraft structures. I took the job here thinking that these power systems, I could eventually make something for terrestrial use and start a company doing it.
So how did you initially come to envision using sound for fire suppression? And how did Sonic Fire Tech form out of that? What is Sonic Fire technology?
It's better than the original name. The original name was Incendium Initiative. So Incendium is Latin for wildfire. And that's what we started thinking about initially. And through customer discovery and really thinking of not how do we just make cool technology, how do we make something that can actually get out into the world and help people, we really focused on the acoustic canon itself. So what was the question here to get into that?
Well, knowing that I'd like to kind of lay a foundation for acoustics and setting the stage for how this technology has been used historically, if it's ever been contemplated in the context of the work you're doing today, and
Gotcha.
ultimately how you came to initially envision using sound for fire suppression, and then how that idea evolved.
The way that Sonic Fire Tech formed. I was working on acoustics. That technology that I developed for use on Venus, I actually licensed to a group out of Silicon Valley, Nirvana Energy Systems, and I left NASA to go lead the commercialization for them. I was there working on building systems for commercial applications, residential, that sort of thing. My co-founder with Sonic Fire Tech, Michael Thomas, he's a lawyer and had been thinking about how to fight fires for a long time. He had somebody close to him affected in 9/11, so was thinking, hey, there's got to be a better way to do this, watching the wildfire situation get worse and worse every year. And I believe he saw work that DARPA had done. Back in 2008, DARPA showed that this was possible. And it's some debate, DARPA did it and Mythbusters did it right around the same time. And both of them basically did the same thing. They used a massive stack of speakers and basically blew out a candle. So they showed, yeah, it'll work, but you've got to use a tremendous amount of power. You're going to hurt people's ears. It's not practical. And DARPA did do larger than a candle. They ended up doing, I think, a bit more than a pan fire, but still a fairly small fire. And they were right on top of it, had to use a ton of power to do it. Then some students from George Mason University made the system smaller in 2015. They had a little handheld thing. And typically, if you Google acoustic fire suppression, they're what you see. So they caught a bunch of national attention, at least. They went on talk shows and all sorts of things. But they were able to take this little handheld thing and knock out a pan fire from a couple inches away, maybe a foot. They were not able to scale it to a higher power and to something that was viable. So my co-founder had seen that and then was kind of Googling keywords around all of that, came across some of my patents and reached out on LinkedIn and said, hey, I got this kooky idea. Do you think this would work? Do you think you could do better with this? So he and I joined forces, went out and got some initial funding to build the first hardware. And that first hardware was basically taking similar things to what they had, going to Home Depot and AutoZone, building something in the driveway. And with that first test device, I knocked out a fire from 7 feet away.
Wow. So there's this old Arthur Clarke adage that any sufficiently advanced technology is somewhat indistinguishable from magic. So for someone not knowledgeable about the physics or how any of this actually works, what is actually going on here?
That's an excellent question. So there's actually a lot of academic research going on trying to get down into the real nitty gritty about how it works. But at a very, very high level, there's 3 things that you need for fire to burn. You need fuel, you need heat, and you need oxygen. So what we're doing is vibrating the oxygen faster than the fuel can use it. So it breaks the chemical reaction and the fire goes out.
From this garage proof of concept to ultimately a commercialization path, can you take us through those more humble beginnings to how you begin to go about securing your first sales or LOIs or larger contracts, and what the path for a company like what you're building looks like?
The interesting thing with this type of technology is it can be used in so many different places. So we have spent a tremendous amount of time talking to people in fire service and then all of the potential industries that we could go into. And we went through I-Core to get our heads around customer discovery and parts of starting a business I'm familiar with from Nirvana Energy, being there from day one in an empty building and pitching and all of that sort of thing. But there's parts of it that I hadn't done before. So go get the help you can, right? So I-Core was great for that, helping us go through the customer discovery. And we had a good mentor who's a local entrepreneur here, Paul Hammerly. He's a good guy, helped us figure out how to ask those questions and not be leading and all that sort of thing. So talked to a bunch of people about which way to go with it. We got our next decent amount of funding from Ohio Innovation Fund, from Glide. And with that, we were able to go and build the next generation hardware that was all custom. We took that and were able to put out a fire from 25 feet away and increase the efficiency substantially. So that's the other trick with it is if you can knock out a fire, that's great. If you're using a terrible amount of power, it doesn't help you too much, because if your building's out of power, you can't really run on a battery if you're drawing too much, or if you're in a remote application, you need too much power. It's not good for you. It's just as bad as needing to carry a ton of water with you at some point. So the efficiency is what really sets this apart from other attempts. And all of that comes from having to make engines that used acoustics that had to be extremely efficient and extremely high powered. All those practicalities are being used here.
How do you think about the position of acoustic fire suppression technology against traditional fire prevention and suppression methods? Where does this fit compared to water? And what have people explored in this market before? And what do you feel are the paths to be explored?
Yeah. It's a really interesting conversation when trying to compare it against traditional techniques. And that's one of the challenges in having the conversation. So if you think about warehouse protection or just a general building, you see sprinklers in a building, that's something we can all envision. Make the sensor on that such that there has to be a huge fire before that sprinkler goes off, because it's going to destroy everything. If there was a false alarm, you've destroyed your product, you've destroyed your warehouse. So all of the testing around if those things work is thinking in that line. It's already a big fire. All of the codes are written thinking about that. With our system, there's no side effect. We don't care about false alarms. One thing I didn't mention is we're running infrasound. So we're below audible range, so we don't hurt your ears. You don't even know it's running. So if our system turns on with an extremely sensitive detector, we can stop a fire from ever evolving. Think about a warehouse where you'd have, boxes stacked up, or an Amazon warehouse or something. They've got a lithium ion battery that goes bad in a box. We have some sort of mobility to get us to it and knock it out, knock that one box out before you've got a 60-foot column of flame. It changes the paradigm in how you're approaching things.
One of those concepts that I also haven't been able to unthink about was this concept that you introduced to me. I literally had never heard of it before, but the idea of an acoustic shield. And so I'd love to just hear how you think about what those are, but maybe more holistically with that, in a world where you're able to kind of realize the technology at a scale that you would like to achieve, what does that future look like? What are the different kinds of applications that you're thinking about? And what might that allow for us to do?
Yeah. What we're being careful about right now is having two prior efforts try to scale this up and not be successful with that. We're running the hardware at the proven level and approaching several markets with this technology, with this hardware. It's also with the amount of markets that we could go into, we could get easily distracted, right? And go design this, change, design that. And I've seen that happen before. So we're using the hardware that we have now, and everybody we talk to, we say, hey, if this power level, this capability is functional for you, we'll continue the conversation, because this is the box we're building. If you want to buy this box, let's end the conversation. And there's several different folks that are interested, and we're getting into pilot programs and things with them. But as far as scaling, everything that we've done, and I say this with a caveat because, as I said, other folks have tried and not been successful, but with the analysis we've done, everything is tracked within a couple % of what we thought it would do. If we take where we're at now and we extrapolate, we can go extremely far with it. There's actually a JPL report. They have a think tank called the Blue Sky that did a report back in 2018 looking at the evolving wildfire crisis and saying, hey, what do we need to actually address this? And one of their key findings was if acoustics could be used, it would be the most effective thing for us. But the key problem was the power usage, and somebody needed to be able to come up with something efficient. In their predictions, they were looking at using acoustics to stand off fires from several kilometers away, and looking at basically putting up a wall to stop a mega fire from encroaching with that. The numbers that we're looking at from our analysis show that that's likely. You're not using 100 watts to do that. You're using tens of thousands of watts, but there's a practical upper limit with what you can do with acoustics. But You can pair systems. You can do lots of things. But you get into the acoustic shield that we discussed, and we think it's possible to put up an effective acoustic shield, basically kick out enough acoustic waves that fire just can't take hold around your house or around a neighborhood at some point. When you have standoff distances of kilometers, you can protect huge swaths of land. We think one of the best uses for that down the road is dropping it in front of fires as they're approaching. So you effectively stop it. Make a fire break with this, because it's very good at preventing fires from starting. When you look at wood, we've done wood, we've done chemicals, we've done several different types of fires. Wood is the worst case scenario, because once it's been burning for a long time, it's got that thermal mass. And if we're not running the acoustics on it while it's still hot, it will reignite. So we have to run the acoustics on it until it cools down, and then it goes out. That's one of the downsides of us versus water. But in a large scale scenario, protecting neighborhoods, making kilometer-long fire breaks are all possible.
An unfortunate backdrop for the conversation today is obviously we're seeing the wildfires in California. It's a perennial occurrence at this point. To maybe help us understand the scale of the problem outside the obvious human suffering, how many homes are at risk with the frequency and increasing frequency of wildfires?
Yeah.
What is the landscape, the broader landscape of this whole attempt to mitigate and prevent the spread and inception of wildfires? What does that whole problem space look like right now?
So the homes that are at risk are in an area that they call the WUI, W-U-I, Wildland Urban Interface, right? So in the US, there's 43 million homes in the WUI, and 4.4 million of those are deemed high risk. So those are the ones that are in likely areas where a fire is going to come in and affect them. And right now, the only prevention, there's alternative manufacturing techniques that they use, like slate roofs and things like that. They're coming up with codes to space landscaping further away from the homes, because the way a home actually catches fire from a wildfire is embers come off the front of the fire and they hit the structure, and they end up accumulating in certain areas. So they'll go up through the vents into an attic, and you accumulate a small pile of embers there, and it's enough to start a fire, and then the structure's gone. Or they go under a deck, or there's a couple key locations that if you can protect those, the home is much more likely to survive. So there are systems out now that are using sprinklers to do that. Sprinklers, or there's a foam agent. The problem with them is if you've got 60 plus mile an hour winds and you turn a sprinkler on, that water's as good as gone.
Yeah.
And they can't use city water because it's all limited. We're seeing that, unfortunately, right now in LA, they're out of water. So the systems that protect an individual home, they have a water tank. So you've got a finite resource of water that you can use to protect. And as the fire comes through and evaporates the water, your house may as well not have even had it. We're looking to make a home protection unit. What we've demonstrated is that we can actually duct the acoustics. So we can have a box and run a duct that circles the home and protects those key locations. So it is something we're looking at doing.
Yeah, it's incredibly cool. And I would imagine from the market perspective, when you think about just how untenable and expensive insurance is becoming in places highly susceptible to these kinds of disasters, there's such an opportunity to build in this kind of technology that can protect the homes.
Yeah, insurance is pulling out completely. State Farm dropped tens of thousands of people last year in California because the risk is just too high. So we've chatted with some of the insurance agencies, and there's some potential there where either they offset the cost of purchasing a system, or let them insure themselves at all once they've actually taken steps to protect the home.
So when you think about this delta between, you've demonstrated from 12 inches to dozens of feet to painting this picture of kilometer level suppression. what do you think are the key barriers, technologically or otherwise, to get to that kind of scale? And maybe simultaneously, the business or market hurdles that you have to surmount, and where you kind of position yourself today and how you're thinking about getting there.
Yeah, so we initially were focused on wildfires. I told you that the name of the company was Incendium Initiative, Latin for wildfire. We were using all of the NASA tricks, designing a drone that could survive in the fires. And before we started really thinking as a business and what can we sell and how do we keep the lights on and enable us to fund the research to grow and do these other things, it's seeing what the business model is that leads us there. And right now we're keeping all of our funding very small. This is another thing that I saw work. I worked at a Silicon Valley funded startup. So I've seen the opposite side where you've got really good fundraisers and you're not focused on making a viable business. So we're keeping all of our expenses very low, trying to fundraise minimally and get us to where we have something that's useful and we're selling it. We're basically funding ourselves off revenue before we go to that next large round of funding that can escalate us. In having all these conversations and doing something that's hard tech and deep tech, showing people that this exists is a hurdle. We need to get to a place where we show that it's not only is the technology viable, but the business is viable before we can take that leap to go and take in a large funding round and go do the bigger things.
What other lessons have you applied from your learnings from Silicon Valley?
Yeah, the one thing we had talked about was staying in stealth mode.
Yeah.
So the company so Nirvana Energy, when we left NASA, there was a press release, and then we were written about in Forbes and a bunch of other places. We didn't have a product yet. So we got the phones are ringing off the hook because people are interested in what we're doing and we have nothing to give them. So it's opportunity wasted completely. So we have waited until we have proven that this works. We've got customers. We're in a place that it's viable before we go out and do any of this type of outreach and let people know what we're up to. I think there's one video out there of what we've done, and we just put that up, and that's testing from a year ago.
Yeah.
So yeah, don't waste that sort of opportunity.
Yeah, it's a prudent approach. I'd encourage anyone to look at the video because it really, I think, instills that Arthur Clarke framing of it. It looks like magic. It's really quite remarkable to see it put out a fire.
Yeah. And what that video is, it's we're about 10 feet away from a fairly large kerosene fire that we knock out, and it takes 2 seconds to knock it out in that video.
How do you think about the role of having built it here in Cleveland and the ecosystem here and just what that's been like?
I think Cleveland is an amazing place for hardware. The amount of engineering talent around here, the manufacturing capability, it's like every other building's a machine shop around here. It is a great place to do hardware for sure. That's been the biggest thing. And with even with Nirvana Energy, they didn't try to relocate us to Silicon Valley because of that. If we were a software company, it would have made sense to go out there. But us getting things machined, we're able to jump in the car and go pick parts up. And there are plenty of shops around here that are willing to knock something out for you quickly if you're on a deadline or held up on a test. It's been really good for that.
What are you most excited about looking forward?
That's a big question. Well, so with Sonic Fire Tech particularly, I think that it's really going to change the way that we approach fires, and particularly on the front end and keeping people from having to deal with fires. Commercial kitchens are one of the first places we're looking. It's something like 80% of kitchens of restaurants that have a fire go out of business because that fire suppression system goes off. It contaminates all the food. They have to evacuate everybody out of the building. It takes a couple days to clean it all up, get the system recertified. So they're down for a week. They run on such small margins. They're out of luck. So something like this can keep businesses in business and really keep people from having to interact with fires at all.
You limited the scope of what you may be excited about to the company, but I'm curious if you widen that a bit. What are you thinking about these days?
Outside of that, it's lots of what my kids are up to. We're getting back into travel baseball. So largely what I do is work on these things and hang with my kids. Those are really my two activities anymore.
Just thinking about, Cleveland and the ecosystem here, how much latent potential do you think there is to unlock with organizations like NASA? How many of these kinds of entrepreneurial leaps and how do you think about what it takes to get more people to take them?
I think that NASA really has a push and is very interested in doing that, but they've been unsuccessful. Other than a couple key opportunities have worked out, but largely not. So I'm actually trying to take advantage of that myself a little bit, and it's really through happenstance and needing to get things done. So we've talked about Sonic Fire Tech, but I have an engineering firm called GhostWorks Engineering. What it is myself and another ex-NASA person who's entrepreneurial and is doing lots of great things on his own. We kept using the same people, lots of folks that were either ex-NASA or moonlighting and looking for odd hours here and there to help get things done. And so we basically formed this group so that we have all these folks that we can go and noodle with the different things we're thinking about. And we have a shop that we can now do prototyping in. And so Sonic Fire Tech is testing there, basically made our own incubator that we're working. And we're using that so that the name GhostWorks is referencing the Skunk Works and
Lockheed Martin.
Yeah. The little aerospace throwback. But the ghost side of it is essentially we're like the ghostwriters behind the scenes with startups in the area. So one thing that we've run into with Sonic Fire Tech in going after government funding was they respond, hey, your engineering team isn't big enough because there's 3 people in the company. So with GhostWorks, you can have access to over 100 years of NASA experience. Those folks are ready to go. And it's basically a fractional engineering team. That's how we're looking at it. So sort of taking advantage of all those resources and knowing that there's a ton of talent. The folks at NASA are eager to do good work. I don't know if you know, but government goes very slowly.
Yes.
There's a lot of internal frustration with folks there that even if their project is moving forward, it's going to take longer than their career to see it do anything. So they're eager to do good things.
Right. And the breadth of interesting problems that you get to explore, I imagine, is pretty fascinating. I recall everything from small scale nuclear reactors to many other things that I think all could benefit from that model.
Right. Yeah. And I haven't necessarily seen anybody do what we're doing before, but we'll see how it goes. We'll let you know.
To round out a forward-looking perspective for Sonic Fire Tech, I appreciate this approach you've used of building you call it the minimal commercially viable product that you can sell to fund the technological research, unlocking the next minimally commercially viable product that you can sell to unlock further stages of growth for the company, that whole cycle. If the goal is sonic shields for the 40 million or so homes at scale that you had mentioned, or these industrially sized machines capable of operating kilometers away, whatever you discover is the right business opportunity for you to run with, how do you think about what it'll take to scale and grow?
At the moment, the order volumes are such that they're almost artisanal, right? We're hand making these things, which there's shops that are machining things for us, and not everything's done. And I say in-house, it's literally in a basement.
Right.
But what I did pick up from Nirvana Energy, we were making a lot of very similar parts to what we are here. So generating acoustics, you're using a similar thing. The motors basically look like an alternator. So at scale, those can be very inexpensive. And being here in Cleveland, there are motor shops. They make electric motors here. So there are folks locally who are making our motors now. Through Nirvana, we were looking at very large scale, selling residential. So hundreds of thousands of units. I do have connections over in Korea if we need to get to that scale, but we're not looking to build our own manufacturing capabilities outside of prototyping. So we're continuing to work with vendors that are willing to do prototype and small volume level, but have the capacity to scale up to the higher volumes so that we don't have to build that capability in-house and we can stick with what we're good at, which is making the next thing and doing the research, doing the development to keep innovating.
Awesome. That's very helpful. Yeah, just trying to understand, what the path looks like ultimately. It's almost reminiscent to me of the kind of SpaceX model where, you figure out the smallest thing you can build that's commercially viable that, helps unlock the next stage in service of the really ambitious thing that you're working towards.
Yep. And largely, yes, it is that. And trying to do it, make it a viable business from the beginning. You could name any number of companies that have been around how long, taken in how much money, they're still not profitable. It's all on a bet about getting to some massive scale to be viable.
Yeah. What other earned wisdom and entrepreneurial lessons do you feel are most influential in your thinking and approach?
Earned wisdom. Be stubborn. That might be the biggest lesson through all of this. Yeah, even the technology from NASA, I was told it wouldn't work. Tried to file the patent and it was put in a desk for 6 months. Pestering, and finally got the opportunity to file the patent. Ended up getting some funding and went and built it. None of the opportunities come easily. And you're going to hear no 100 times, maybe 1,000 times to the one yes. So keep at it, ride the roller coaster of emotions that come with owning a business. Just stick with it.
Yeah. What do you feel keeps you motivated? What does success ultimately look like?
I just think there's such massive impact for this. I can't take no for an answer at this point. We'll just chase it till we get it done.
Yeah. I certainly hope you do. It's really one of the coolest ideas I've heard. So I would love to see it happen. So we'll bookend our conversation here with a traditional closing question, unrelated to everything we've talked about so far, but for a hidden gem in Cleveland, for something other folks should know about, but maybe they do not.
Yeah, I came up for my first internship up here in 2008, I think, and didn't know much about Cleveland. And one thing I was very surprised by was the metro parks. And I got into mountain biking when I moved up. That's something I wouldn't expect. And whenever we bring friends and family up here to visit, we always take them out, and everybody's blown away by that. So that's what I'll say there.
Perfect. It's a wonderful hidden gem. Well, Geoff, I just want to thank you for coming on, sharing a bit more about your story and what you're building. Again, I find it really inspiring, and I'm optimistic and hopeful you can make it happen here.
I appreciate it. Thank you for having me on.
Absolutely. If folks had anything they wanted to follow up with you about, where would you direct them?
The easiest thing is if you go to sonicfiretech.com, there's a contact link there, or find me on LinkedIn. That's what it's worked out in the past.
Perfect. Thank you again.
All right. Thank you so much. Take care.
That's all for this week. Thank you for listening. We'd love to hear your thoughts on today's show. So if you have any feedback, please send over an email to jeffrey@layoftheland.fm or find us on Twitter @podlayoftheland or @sternhefe, JEFE. If you or someone you know would make a good guest for our show, please reach out as well and let us know. And if you enjoy the podcast, please subscribe and leave a review on iTunes or on your preferred podcast player. Your support goes a long way to help us spread the word and continue to bring the Cleveland founders and builders we love having on the show. We'll be back here next week at the same time to map more of the land. The Lay of the Land podcast was developed in collaboration with the Up Company LLC. At the time of this recording, unless otherwise indicated, we do not own equity or other financial interests in the company which appear on this show. All opinions expressed by podcast participants are solely their own and do not reflect the opinions of any entity which employs us. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. Thank you for listening, and we'll talk to you next week.